thank you for sticking around. I'm not sure if I would have actually been in the audience if, with all the competition outside and everything is so interesting and so great. But I hope I can entertain you in the next 20, 25 minutes and talk about something that I'm sure it's very close to our heart of all, because we are all interested in VR, AR, sometimes people call also MR, mixed reality. And from standardization point of view, there are a few things that I wanted to kind of share with you and tell you where especially the JPEG Standardization Committee stands. Before that, I don't think I need to really introduce JPEG as the file format to you. But maybe one thing you don't know is the JPEG as the committee, the Joint Photographic Experts Group. In fact, JPEG is a bunch of people who get together 3 to 4 times a year all over the world for 1 week. And we try to define the file formats of image and video in the future. We are officially under auspices of 3 organizations: ITU, International Telecommunication Union, which is part of United Nations, but also ISO, which is actually not International Standard Organization, but International Organization for Standardization. Nobody knows why the acronym doesn't follow really the first letters. And the IEC, which is International Electrotechnic Committee. Now, one thing I want to start with is that I hope you all agree that the JPEG as the file format that has actually made the JPEG name to become almost like a brand name. Many of you do not maybe know this, but it became an international standard in September 1992. So in a few months, it's going to be 25 years, quarter of a century. This technology has been standardized, meaning that the technology must be 30 plus years old. Now, for such an old technology, it is amazing to see how successful it has been. And to make my point, I draw your attention to this chart. You don't need to really look at all the details, but one thing you see is that you have some years and then these columns. Each column is showing you how many images per day are being shared on only the social networks, the 5 social networks you see there. So not WeChat or many also Chinese and other social networks that are also very much used out of Europe and North America. And one thing you can immediately see is that the growth is, first of all, exponential, meaning every year is almost twice the year before. And the other thing that is very interesting is that as of last year, actually even 2 years ago, because it's 2015, the number of images that were shared in JPEG were more than 3 billion per day. So today, and I think in 1 month, these statistics are going to be renewed for 2016, this number is going to be close to 5 to 6 billion per day. So we're getting close to the number of population on Earth, 7 billion, right? Now, and take into account that this is only a tiny part, right? It's not the number of all JPEG images that are taken, captured every day. It's the number of images that are being shared only through these, of course, admittedly very, very popular platform for sharing pictures, but not everything. So you could probably very comfortably say that there are billions of images in JPEG format being created every day. What does it mean? It means that this standard created and has created, continues to create a very strong ecosystem. We have heard this word, ecosystem, in the past 2 days, this morning also. And I hope that you keep thinking about ecosystem. If VR, AR, MR has to become successful, we all need to create an ecosystem for it. Now, ecosystems are not always so rosy. In fact, JPEG has another one called JPEG 2000. I took this one because everybody thinks JPEG is only pictures, but actually JPEG is also a lot about video. And in fact, when you go to cinema, if your theater is digital, which is more or less now almost every theater, at least in Europe and North America, more than 85–90%. The format actually used is JPEG 2000. Another actually format the JPEG committee created. If you watch sport events, the pickup from the sport location and the truck and even inside the studio for doing whatever processing that may be required. These are all in JPEG 2000. And JPEG 2000 is also used for a number of other applications. And it has also created an ecosystem. It is successful, at least digital cinema and broadcasting world is using it. And here another example of creation of an ecosystem that has been not only because of existence of file format, but also because of existence of file format seen the day. Now, interestingly, let's go back to pictures. You know that photography is about 125, 130 years old. And those pioneers who created photography, not digital, but photography, they really had a great vision. One of them is this gentleman, a French Nobel Prize winner, by the way, Gabriel Lippmann. And he is known as the father of color photography. So he's the guy, actually, the technology developed was really for a very long time, the technology that was used in color photography. His vision was not limited to color photography. In fact, he was saying, the most perfect photograph currently show only one aspect of reality. But in fact, can we ask photography to render all the richness of the real world? It's a little bit, leading into this world that we are now talking about in the last 2 days, and everybody is talking about also, right? Of course, technology was not ready at that time for this. Of course, people, since the time this kind of discussion took place, which was almost in the beginning of photography, I've been always asking, should photographs, including videos, be flat? Or can we actually have it 3D? And I'm sure you have all heard, some of you maybe have been involved to some attempts, for instance, 3D, even recently, but in different waves actually, in the last 100 years has come in different waves. For a while, it has been very successful, and then it has vanished. And here we have the same example. Here you see actually a bunch of things that happened in the last maybe 10, 12 years, maybe a little bit more. We saw actually a peaking of 3D photography or video. We even were hoping that not only game consoles, but even our television sets at home will become 3D. We even have seen standards that were created. And we know what happened to it, right? I don't think that I need to even ask how many of you are watching television at home in 3D. Because first of all, you need content for it. And secondly, most people, what is interesting is that 3D attracts them for a while. It's usually a show-off. It's the curiosity sometimes. But very soon, the excitement vanishes. Why is that? Why is it that 3D television, 3D video and image vanished? The only place where it is still surviving is in cinema, by the way. Digital cinema, and by the way, that is JPEG 2000 that I just told you. That's the only place. Well, the reason was because it didn't really hold on the expected user experience people needed. And I can help myself. to think that we have to learn from the mistakes that happened. So I think a question that we all have to really ask ourselves is, today, VR, AR, MR, where is it going? Is it going to be, and hopefully become as successful and create the equivalent of ecosystem in digital photography or digital cinema or digital broadcasting, as it has happened? Or is it going to become the fiasco of 3D TV? And you think about it, there were a lot of similar parallels. We have to be, I think, very candid and very honest about that. Nobody has really the answer for this. So JPEG committee is trying to actually help in there. It cannot do it alone. It is going to help and facilitate at least part of the problem to be resolved, part of the obstacles to disappear. And the timing is good because we see a lot of rendering solutions to, a lot of capture solutions to capture reality. And we are seeing also a lot of solutions that are rendering and displaying to us what we call immersive content. So that's great. This is great. This is happening. In addition, and I don't need to actually even say probably too much about that, we are also having new type of content that is created. And you don't believe me, just go downstairs and you will see, all sorts of great things that are happening there. And these three elements, plus a few other things that people have been talking about, I don't want to take your time here, are creating this perfect storm. And what is really missing is a great file format that can contribute creation of this ecosystem I told you about. And that is where JPEG committee is stepping in. So we started actually this activity. Our hope is to have a very high quality and photorealistic, immersive content. A lot of things that we saw, they're all great, no doubt. But you could sometimes ask yourself, the same way when the first digital photos were captured some 20 years ago as products, and they were really very pixelized, they were at most VGA, they were interesting to see, but now compare what we have today and what we had 20 years ago coming out of our cameras. I think that this content, in many cases that we are seeing, can become much more realistic, much more high quality. And the quality doesn't mean increased resolution. It doesn't stay actually at that level. You need much more. Plano in Planoptic actually refers, and don't worry, I'm not going to give you math, education now. I just want to draw your attention to the fact that Plano actually comes from a mathematical concept that has been around for a while called planoptic functions. It says the world around us, instead of looking at it as a flat or even 360 as people do, you could do much better. You could actually represent the real world in 7 dimensions. Every point in space radiates in every direction. Its color and its texture, and you add them up plus time, it gives you actually the 7 dimensions. So it's 7 dimensions. Pictures and videos are 2 and 3 dimensional. Imagine 7 dimension, the minimum is that it's a much, much bigger volume of information, and you have to compress it. So and this is what JPEG wants to do in the framework of JPEG Plano. But we started 2 years ago, around 2015, looking at panoramas. These are the cylindric surround content. 360 VR, something we see today almost everywhere. But actually, these are just the start. These are equivalent of the very low quality pixelized low resolution images that we were seeing 20 years ago. There is huge room for improvement, but that room for improvement can only happen if you really fundamentally change the day you represent things. There are things people talk about like depth photography, like light field photography, point cloud, and ultimately holography. I want to walk you through this in a more entertaining way instead of boring you about what each of them is. So the first one I'm going to show you is depth photography. By the way, everything I'm going to show you is coming from a given either prototype or even product.
Camera depth-enabled tablet. It will change the way you take and share your photos. By capturing a high-definition depth map optimized for photography, along with your full-resolution image, Intel is enabling a whole new class of photography. Capture depth. Reveal more. Change focus with the touch of a finger. Add dynamic effects. And discover things in your photos you never thought were there. Flat, static photos are out. Intel brings you photos that tell a story with more dimension. Photos that inform, surprise, and inspire.
Okay. So that's one example, all right? Of course, the file format is proprietary, but these kind of things, Intel and other companies have the technology today to create. Let me give you another example, a completely different representation.
My name's David Rooney. I'm the Science Museum's Curator of Transport. The Shippen Galleries opened at the Science Museum in 1963. It's the biggest gallery space in the museum, and it was stuffed full, over 1,000 absolutely remarkable exhibits. Genuinely historic stuff. Every time I walked through, I found something I'd never seen before. After half a century, though, it was time to close the doors. It was time to make way for new exhibits. But we wanted some way to preserve the old Shippen Galleries, and I was really excited when we got the chance to have the whole display laser scanned. 2 billion precisely measured points. And so now we can make a virtual model of the galleries. We can see them in an entirely new way. It's a unique permanent record of a unique historic exhibition. It lets us fly through the gallery.
I guess for us all here, we all relate to this, just that this is not coming from a 360 camera, and it's not a synthetic texture plus mesh, as people in VR have been using. This is point cloud. It has been around for a while too, and technology is now good enough to actually create point clouds. And by the way, what you saw is already 3 years old. There are even better sensors that capture much higher quality content. Now, there is also something, a word that we hear. Actually, I've heard it a couple of times here. I would have liked to hear more even. It's the light field representation. Light field is very close to this planoptic representation. In fact, in French, it's the same word. Light field in French is planoptic. It's to be able to capture as close as possible to 7-dimensional representation I told you. Can I have the video very quickly? So this is one way you could capture it with multiple cameras. Again, this is not a 360. This is a camera that is moving around the person. And you can imagine that actually can move in many other directions too. There are a lot of work like this that has happened. Or you could use a trick in optics called use of micro lenses. And that also gives you very interesting results. Can I have the video for this one?
This beautiful futuristic camera is the Lytro Illume, and it's unlike any camera you've used before because it can do this. The light field resolution of this camera is 40 megarays. Unlike a traditional sensor, it not only measures how much light is hitting the sensor, but which direction the light is coming from. And that's why it can focus on different planes in the picture even after you've already taken your shot. What I like about the Illum is that it gives the artist and the viewer a different experience when looking at a photo. Not only do you get to frame your picture and have people think about the composition and your subject, but you get to let them travel through each focal plane, experiencing an entire environment in a new way. I have to say that using the Illum was a magnitude harder than regular photography because you have to plan your shot perfectly. You need something in your foreground.
Okay, for interest of time, I'm going to move to the next one. It is also a technology developed by Illum, but this time by Lytro, but this time for video. Just for those of you who are less interested in photography, more in video.
As a visual effects artist and supervisor, I've always been curious about what's next. It sometimes feels that visual effects can sort of slow things down. I think we're now at a point where you can not interrupt the flow of work and keep the creative direction constant.
If you get me more coverage, I'm able to make the movie you want me to make today. If you only just shoot it in one way, I'm locked in.
What is exciting for me about this camera is that it is headed down a path in imaging that I've always wondered whether it was possible or not. This is proof that it is possible.
Video until now has been a 2D medium, and computer graphics tend to be three-dimensional. Cinematographers and visual effects artists are doing amazing things, but they have to struggle through the fact that these are two different mediums. What light field allows you to do is that it integrates the two worlds. It turns every frame in a video into a three-dimensional model.
Light field cinematography is the ability to capture everything about a scene from different perspectives, different focal planes, and different apertures. Every pixel now has color properties, directional properties, as well as exact placement in 3D space. Essentially, we have a virtual camera that can be controlled in post-production.
Lytro Cinema offers the ability to focus anywhere in your scene. You have the infinite ability to focus and create any aperture or any depth of field. You can shift your camera to the left, you can shift it to the right, as if you had made that exact decision on set, and you can even move your camera in and out. Automated camera tracking removes that tedious task of integration and matchment. It has all of the volume, all of that depth information that easily allows you to composite and matte your CG objects. With depth screen, it's as if you had a green screen for every object. But it's not just limited to any one object, it's anywhere in space. When you capture in the high bandwidth mode of Lytro Cinema, it gives you the ability to then reconstruct any shutter angle and any frame rate. So this allows you to use...
Okay, so this shows you actually, there are a lot of technologies out there, right? It requires, by the way, this video that is created that can allow you to move around and change things and focus in, out, zoom in, out, etc. These are huge amount of data. And they have to be compressed, and we work with these companies, that's JPEG, in order to be able to agree on a common format so that you are not locked into the workflow or the results of, the formats of just one single company. Of course, in holography, a little bit later on, we are also looking at that direction. I have not good news for you. Star Trek hologram are not, Star Wars, sorry, holograms are not yet around. The technology is not ready. And but actually there are a lot of holographic capture devices. Holography microscopy is one of them. And in fact, we are working only for the capture part. For medical imaging, also on the holography representation, but for now, it's not really for entertainment and things like that. So let me show you just the schedule. In fact, the first phase of a lot of example I've showed you is going to be finished early 2019. So because it takes time for people after the standard is defined, to start really building products and services and things like that, I would say that there's a good chance if everything goes well, by early 2020, late in 2019, there will be actually products coming out. Let me finish everything here. Everything I showed you was real, except this one. The vision of JPEG committee about what the future of VR, MR, AR will be. as opposed to today, being mainly 360 video. I think it's very well captured in an ad by Intel for their MR headset they call Alloy. It's another product. What you see here is not coming from their product. It's just a mock-up, as you say. But I think it actually gives you a very, very good picture of what we are aiming, and hopefully we will have the format for that.
You got that thing, baby. You got that thing, baby. You got that thing, baby. You got that thing.
What if you could experience every moment in ultra-real high fidelity? What if you had the power to change the story?
Okay, thank you very much. I would like to thank you for the time, and if you want to discuss more, know a little bit more about the details of these things I just passed through at very high level, I'll be around today and tomorrow. Thank you.